Dear students, in previous videos, we have seen how we are representing each document with respect to our query. Means what are the models we are using to represent the document? The models that we have seen was vector space model and simple term weighing and binary model. Now, in this unit, we will see how we are going to make a document relevant to the query based on the probability, and what are the different models which will decide the relevance. There are two types of the models. One is a binary independence model, which is in short called as a BIM, and another one is a non-binary independence model, which is in short called as a non-BIM. So let's start with the video. Now, the question will come to our mind that how come probability term is coming in information retrieval? We know that why we are going to retrieve the information, because user has some information need. Okay. Now that need he will type in form of query in the text box of search engine. Okay. And we have a collection of documents. Now, these documents we are representing using different models. As I told you, vector space model, which is in short called as a VSM. Okay. Now, from this document, any one of the document I will give as answer to the user. Now here, 2 points you should understand that user need is not constant. It is continuously changing. So user need is uncertain. So there is an uncertainty in user need. The second thing that you should know is as user need is changing, the document that should be given as an answer to the user should change. Means the relevance of the document will be also uncertain. So whenever the word uncertainty will come, you should think of probability. Okay. Now in vector space model, we have seen that there is a relation between the document and query, and that is represented using similarity index. Okay, we have used the cosine formula there. Now, probability. Now, probability is helping us to find out the answers to the uncertainty. Okay, and probability is helping us to quantify our uncertainty. Now, how it is helping us? Now we know that we have a collection of document in the database. User is issuing a query. A list of the document is returned as an answer to the user. Okay. Now, which document should be returned to user as an answer to the query is decided by the relevance of that document to the query. And based on that relevance only, ranking is assigned to the document. Means the most relevant document should be returned first. So the best document I am returning first. And then after that, second best document I will return. So we have seen in Google search engine that the most relevant website, okay, that is giving answer to our information need, that will be appeared in the top. Then below that, less relevant. Like that, they are arranging the sequence of the websites. Okay, so each document we are ranking based on the probability of relevance. Okay, now how we are finding it? That when a particular query is given, whether a document is relevant to that query or not, we want to find out its probability. If it is relevant, we will say it as a 1. If it is not relevant, we will say it as a r is equal to 0. Okay. Now, we all know that probability means what? Event should come to our mind. Okay. Now, let us consider that there is an event A and B. We all know the famous statistic rule, that is the Bayes rule. Okay. Now we know that using Bayes rule, we are trying to find out how much two events A and B are dependent or independent of each other. Okay. Now, conditional probability A given B is given by the conditional probability of B given A multiplied with the probability of A divided by the probability of B. And the same thing I will express in terms of joint probability. Okay. Here I will express it in terms of the joint probability. Now here you know that the probability of A is known as a prior probability. The probability of A by B is known as a posterior probability. Now here I need one more term that is called as a odds. Now what odd is helping me to find out the likelihood of a particular outcome. Now here what is our outcome? Whether a particular document is returned as an answer to query or not. When it will be returned? When that document is relevant. So that probability I want to find out. Then what odd is telling us that probability of A is divided by the probability of A complement. Then how I can find out the A's complement? By 1 minus probability of A. Just remember this formula. In upcoming slide, we have to apply this formula for probability ranking principle. Okay. Now, what is the probability ranking principle telling me is, in the collection of document, X is representing me one document. R is representing the relevance of that document with respect to the query. When R is 1 means what? It is relevant. When R is 0 means what? It is not relevant. Okay. Now, how I am going to find it out? Now, apply Bayes rule and get these two formulas. Okay. By applying the Bayes rule, I will get these two formulas. And I know that probability of R is equal to 0 for a particular document X plus probability of R is equal to 1 for the same document X is equal to 1. That is the probability of A plus probability of A bar is equal to 1. This formula you should remember here. Okay. Now, here, what do you mean by probability of R is equal to 1 and probability of R is equal to 0? Means when I'm not considering the X, then here what you should remember is, here I'm trying to retrieve a document. It may be relevant or it may be not relevant. So that is given by the prior probability. Then in the second case, when I'm including X, then in that case, I should find out the probability of the retrieved document X, whether it is relevant or not relevant. Okay. So what the probability ranking principle is telling us is, find out this R is equal to 1 and R is equal to 0. So for that purpose, you are going to take help of a binary independence model that we are going to learn. Okay. But here, what is the main motive behind this probability ranking principle? I want to find out the relevance of each document. But I want these documents to be independent of each other so that their relevance is independent. Why I want this independency? Because I don't want to give duplicate data to the user. Here, if I'm giving the same repeated data to the user as the answer to the query, then user will stop using my search engine. Okay. User will don't prefer my search engine. So here independence is important. Means I don't want a duplicate data. Okay. So this duplication can be avoided by using the independence model. Now, here, how will be our retrieval strategy? To find out the relevance, I will take help of the weighing terms, which were the term frequency, the document frequency, even one more idea, that is the inverse document frequency. And here, one more new term that you should keep in mind is document length. Okay, so these are the factors which are going to affect the document relevance. Okay, now I should find out the document relevance probability by some combination. So how I am going to do it? Now here, don't forget a very basic principle that when a query is posted by user, I will return some documents to the user. I know that these documents are relevant. Now, if these documents are relevant, then they should be given some weighting in searching. Okay. And this weighting should be based on their relevance. So for this purpose, I will assume how the term in the query is distributed in the document. and how I'm going to use the Bayes theorem to derive these weights. So these all things you should keep in mind before we are going to move in next video, in which we are going to see the two models, that is binary independence model and non-binary independence model. Now keep in mind that if it is related, we are giving the value as 1, and if it is not related, we are giving the value as 0. So based on that, R is equal to 1 and R is equal to 0. Based on the two possibilities, we are naming it as a binary independence model. So in upcoming video, I will like to explain you the binary independence model and non-binary independence model. So I will stop this video here only, and let's continue the same topic in next video. Thank you.